So Doc, what do we have for my cancer?
Well, there's this new treatment that uses molecular machines that kill your cancer cells.
Molecular machines? Come on, Doc. Tell me to stop drinking or smoking. Don't give me nonsense about becoming the next Terminator. What are molecular machines? That's a very good question. Molecular machines are proteins and macromolecules around 20 nanometers that create mechanical movement when exposed to certain stimuli. A molecular machine is similar to a Swiss Army knife in that they can perform many useful functions, but on a molecular level.
For example, these naturally occurring kinesin molecules, powered by ATP or cellular energy, walk along a microtubule road to transport glucose and gases throughout the cell. Like a mailman, but they still deliver on Sundays. It seems basic, but these movements are instrumental to a cell's day-to-day life.
Researchers draw inspiration from nature's molecular machines to create new synthetic ones. For our patient with cancer, researchers are currently designing from nature to create a molecular machine jackhammer therapy. Using near-infrared light, we can stimulate the jackhammer cells to vibrate at 40 trillion oscillations per second until the cancer cells dissipate. So for context, a typical jackhammer used for construction vibrates at 30 times per second. So what's great about this procedure is that it's non-invasive and does not require an incubator to store the therapeutic, meaning it is potentially more accessible to communities that don't have a robust system.
In the 1990s, J. Fraser Stoddart created an artificial molecular shuttle based on mechanically interlocked structures, similarly found in nature. Stoddart and other scientists such as Jean-Pierre Sauvage and Bernard L. Ferenga continued to develop artificial molecular machines that reacted to different stimuli, such as a change in the environment's acidity or temperature, and they eventually earned a 2016 Nobel Prize for their work. Looking into current research, some researchers, inspired by muscular tissue, have designed a network of manufactured molecular machines that contract like muscles. It's a tiny, microscopic muscle that can create movements useful for circuits or programmable robots. Others mimic virus machinery to create a molecular syringe that injects cations into the cells. This can be a game changer for how we currently deliver drugs via a smart drug delivery system that can release on demand, like a valve. Because these molecular machines' functions are unique to a change in their environment, these machines can be applied to computing as components in a circuit, designed to be a more efficient catalyst in manufacturing other molecules, and be instrumental in defeating diseases which may be caused by faulty existing molecular machines.
However, there are technical challenges to overcome, such as Brownian motion and energy usage, before molecular machines are ready to revolutionize medical treatment.
Brownian motion? What's that? A new dance move?
Brownian motion, or the random motion of particles in a medium, can make it difficult to control the movement of molecular machines within the body, a challenge for targeted treatment.
Energy usage is another consideration. While biology is highly efficient at using ATP as its fuel in naturally existing molecular machines, researchers are striving to improve the efficiency of artificial ones powered by other chemicals and light. There still needs to be a lot of research done to optimize these treatments. Good morning, Ronaldo. Thank you for coming in today. How have you been feeling since our last appointment?
Honestly, doctor, I've been feeling a bit worried. Can these molecular machines be used to hurt me? Or worse, my dog?
I'm sure your dog will be fine. There's always a risk when dealing with advanced technologies that can manipulate biological systems, with the potential for bioterrorism and unforeseen genetic mutations. There's a lot of ethical concerns as well regarding humanity's role as stewards of nature. Some are concerned we're playing God and altering or creating new molecular machines without understanding the consequences it may have for human evolution, considering nature has evolved these natural molecular machines for millennia.
I hadn't thought about that. Alright, do we know what kind of side effects are involved?
One challenge we face is predicting how the body will react to these molecular machines. The human body is incredibly complex, and there's so much we don't fully understand. Ronaldo, I know this is a lot to take in, but I want you to know that we're here to support you every step of the way. We'll continue to monitor your condition closely and adjust our approach as needed. We'll get through this together.
Thanks, Doc. After witnessing this doctor-patient interaction, now let's dive deeper into the broader implications of this technology. Joining us today are Dr. Eric Johnson, a biotechnology researcher, and Dr. Sarah Lee, a political analyst. Welcome, everyone.
Let's start by discussing the stakeholders involved in the development and deployment of molecular machines for cancer treatment. Dr. Lee, could you shed some light on this?
Absolutely. Stakeholders tend to fall within one of four categories: governmental, private, academic, or nonprofit. Like most tech, governmental agencies like the National Institute of Health provide the bulk of the funding. Then there are private companies like Momo Therapeutic with investments of $150 million dedicated to just R&D. These companies build on research that began at academic institutions like the University of Strasbourg, And nonprofits, like the Center for Responsible Nanotechnology, ensure the technology is developed responsibly for healthcare providers, patients, and society at large.
Fascinating. Now let's explore some of the social, political, and ethical implications of this technology. Dr. Johnson, how might the introduction of molecular machines into medical practice impact society and politics? Yeah, so from a social perspective, there's likely to be public scrutiny and debate surrounding the safety and efficacy of these treatments. So imagine sitting in a doctor's office and being presented with a never-ending list of side effects. The mere mention of manipulating or enhancing natural processes on such a fundamental level could spark fear about eugenics among the public as we blur the line between normal and faulty molecular machines. Politically, the emergence of nanotechnology and biotechnology with unknown side effects may raise regulatory challenges and questions about governmental oversight.
However, despite these concerns, these therapeutics are a game changer for chronic diseases like cancer. Traditional chemotherapy treatment involves drugs that target both cancerous and healthy cells, leading to nausea and hair loss, symptoms typically associated with cancer treatment. Molecular machines can provide a more targeted treatment that can minimize these side effects. This has incredible impacts for patients who are maybe worried about not being able to go see their favorite baseball team play or cook their favorite food on Fridays because of chemotherapy. Molecular machines has the power to be the next bioweapon or perhaps the next revolutionary cancer treatment.
Interesting. The ethical dimensions of this technology are profound. As we navigate this brave new world of molecular medicine, it's imperative that we engage in robust dialogue and ethical reflection to ensure that we wield these powers responsibly. Well, folks, that's all the time we have for today. I want to thank our panelists for their insightful contributions.
Overall, it seems molecular machines have the potential to drastically advance human health. While there's no price point on these therapeutics quite yet, as the technology is still being explored, ethics, lawmaking, and regulation need to catch up to guide the technology and its untapped potential in the right direction to extend life expectancy and eradicate certain diseases to the pages of history.
Join us next time as we continue to explore the frontiers of science, technology, and ethics. Until then, stay curious, stay informed. Goodbye for now.